Okay, this is day 3 of VZ332 laser cutter. And today we have a dilemma. I've been researching what laser cutters can cut. And regarding to plastic, it's basically about nothing. I should have done this research a long time ago. But acrylic you can only cut like 3 millimeters. You can only cut black acrylic or some opaque acrylics. Polycarbonate releases dangerous fumes, and then anything else is a no-go really. The diode laser cutters are really only good for cutting wood and thin sheets of plywood. So I've been thinking about, instead of building a laser cutter, we build a CNC. Now CNC would require a more robust frame, which is why I got the Ender over. That thing has some 4040s on it and some more 4020s. So the goal is to build a CNC, because the majority of parts I want to fabricate are going to be polycarbonate, and really it's just going to be polycarbonate. So the goal is to build the CNC without buying any additional parts, because as soon as we buy parts, we get outpriced by this thing. The 3018. This thing is $200. And I can't let myself get beaten by this thing. This thing uses NEMA 17 motors, steppers, with the same lead screws that we have. So I think it shouldn't be too hard to build this, but maybe just slightly larger. There's two styles of CNCs like this. There's the Cartesian style, which is the bed moves, and there's the Core XY style, quote unquote, which is you have two linear rails on both sides, and that moves the entire gantry with it. So I'm considering those two options. This option, I could probably just adapt one for one on the Ender, and I wouldn't really have a problem with that. On the Ender, all you have to do realistically is to just hard fix two of these 2020s on the frame, and then that would be pretty much it. The bed would be the same, but you would be stuck with a 235 by 235 bed, which is all right. It's not the best. So I want to see what I can figure out with the Vzbot frame. So right now I'm thinking of using the two 8mm rods as the support. I could realistically, if I wanted to, do 3, but then I need to buy another set of bearings. But I don't want to buy anything for this, because we're already $110 down. No, we're already $200 down from the Milcher saw and then the components. But I can return some of the components because we're not building the laser cutter anymore. So yeah, that's the goal. I'll do some CADing and I'll think about how we can make this into a laser cutter. Sorry, into a CNC. So I was thinking 2 linear rods here. Then we have the 2 linear rails on both sides that we can just take from the gantry. And then we can have motors on this side with a simple belt that goes across the linear rail. I'm not sure how effective belts are. The 3018 only uses lead screws. The thing I like about this a lot is that there's only 2 lead screws, 1 and 2. Well, no, there's 3, but you can ignore that one. That one is for the z-axis. But for this scenario, if I wanted to make a Core XY version, I would have to have mirror it on that side. I would need 2 linear rails, 2 sets of motors and belts, which I do have, but it's just more complicated. Yeah. And then I would still need a way for the x-axis. One of the few things I'm concerned about is if those NEMA 17s are able to handle the speed of this. Well, I do have those speedy 2504 ACs on the Vzbot that are definitely able to. Probably able to. I shouldn't say definitely, because I have no experience with those. But I don't think a bed style is going to work in this frame, because I have the Vzbot bed frame over here, and it barely fits in here. So I need to do some thinking about this. But yeah, we've pivoted. Because I think a CNC is far superior in terms of material flexibility. I think lasers might be more precise, but CNCs, you can just mill anything with them. I'm probably mainly going to do polycarbonate. And if it wanted to, I could always attach a laser onto the CNC. But I can't do the other way around because lasers are much more brittle. Oh, the bad thing about this is that I won't be able to use the the carbon fiber gantry because I'm gonna upgrade to something more rigid. So there's that. All right then, I'll think about it a bit more. I got a bit of parts from, this was the original Tronxy X5 SA before it got converted into a Vzbot. So we have the original bearings for the linear rods, and then most importantly we have these Open Builds Open Builds V rollers. I think we might have to use this for the X gantry for whatever CNC we're building to save costs, because otherwise I would have to get 2 sets of linear rails to move forward and backwards, which is gonna be like another $50, which is a fine cost, but I don't want to spend any more money on this. We have 4 sets of these. I'm actually missing 2 wheels on this. It's funny to me because my entire life in 3D printing has always been to reduce weight, reduce gantry weight, and make the gantry as flimsy as possible with as possible you can, in order to increase acceleration both ways. But now I'm trying to, these things were built for a reason, because these are pretty sturdy. But I obviously didn't like them at the time because I wanted something more lightweight. So yeah, I'll see what I can do with these parts. We also have these, I think these are acrylic motor mounts from the Tronxy. These might make a comeback. So we're just building a Tronxy again. That's gonna be fun. Alright, I'll see what I can do with these parts. Okay, so this is a possible solution where we use the 2 Z-axes from the Tronxy and add that onto the linear rods. But I don't like this solution. This is like reminiscent of a Cartesian. It is a Cartesian at this point because the bed slides back and forth. But that means that it's incredibly inefficient in space because you have, essentially your frame has to be 2 extra bed width. Otherwise your bed can't be milled the entire way. So I think we're gonna stop here and just decide that we're not going to do Cartesian. So at that point, then the question becomes, what do we do instead? And to be honest, I have no idea. Well, the only other option besides Cartesian is what I talked about before. It's that we have 2 linear rails, one on this side, one on this side, driven by motors with belts, because I would need to buy lead screws or ball screws if I wanted to go that way. I think if I'm just milling polycarbonate, belts should be fine. That's what I'm hoping. I have no experience with this. And then we can have another motor over here that's just the same thing. This is just a normal gantry at that point. And then for the x-axis is where things get interesting. We could either just have 2 of these 2020 extrusions, or we could use the rods. We could have the bottom and top rod set up like that. Or what we could also do is that we could have 2 of these extrusions also set up like that. That would be interesting if we had 2 extrusions set up like that. And then because we have 2 sets of those V rollers, we would get 2 sets of extrusions. And if you could find a way to combine those V rollers, yeah, that might be a feasible idea. And then belts. Belts would be pretty easy on V-rollers because you just slot them. I think there's just a slot, if I remember correctly. Yeah, on the Tronxy there, there's just this slot for the belts. Yeah, and then we would just not do Core XY because Core XY is a pretty bad idea on CNCs because the more belts you have, the more flex you're gonna give. Which is not really an issue in 3D printing again because you don't need that much torque. I think that might be the idea. For the Z-axis, it's gonna be really easy. We just take one of those stepper motors, and then we just put one of those toothed, not idlers, tooth flanges on them, and then have a mini belt that goes to the front and have a let screw that moves the tool head up and down. But I think I'm going to start catting this design. It seems like a pretty good design to me. If you do a quick estimate of how much build area we're going to get with this, so let's assume that this is as far as we can go. But then realistically, with the spindle's going to move it forward around an inch or 2 inches. And then side to side, we also have that. So this is just going to be side to side space that we cannot mill. So this looks like to me that we're going to get about, that side is around 15 inches. This side is going to be 15 by 14 inches ish. So not bad. That's acceptable. Because we're really going for small form factor here over speed or bulk. Because again, we're only going to be milling polycarbonate. And maybe some other plastics, but not metal. And not wood either. So I think we should be fine. With plastics, is that you have to go fast. You have to go fast otherwise the plastic starts melting. Plastic starts melting and it's going to be printing again. Alright then, I'll get catting. Okay, I got the gantry up here, so you can see about roughly where the gantry is. Now, this is going to be a lot of work if I wanted to redo the entire gantry, because that's one of the reasons I wanted to stay on the VZ platform, is that I already have the gantry made. So what I'm thinking is, we finished building the gantry like I intended to. At most, I think we can replace the carbon fiber gantry with just a 2020 extrusion again, and see how the rigidity on that thing is, because I really do not want to redo the entire gantry. That seems like a lot of work. I think I figured out an acceptable amount of compromise. So I'm gonna use a 2020 extrusion to replace the carbon fiber that's on the gantry right now. I'm gonna remove the MGN rail, and I'm gonna put one of those V rollers on it. That should give me more stability in this gantry. Now, the other part of the compromise is that I have to design something that would allow the belts to work on those V rollers. I think that's a pretty good compromise. I don't have to redesign the entire gantry. I just need to figure out how to get V rollers on there. Secondly, I think I'll take a play out of Vzbot's playbook, is that instead of making the frame really rigid, I'll try to find a way to make the spindle really light. But still there's going to be vibrations and stuff, but I'm thinking already of just having a NEMA 15 or smaller motor than 17s to be controlling the Z-axis. Why is it phantom zooming? Something like that. I don't know. We're just going to put that on and see if it doesn't work. Then we'll find other solutions. Then we might actually have to go, the full CNC setup with the linear rods. And these are 8mm rods. So if we really wanted, we should probably get 12mm rods. But again, I don't want to spend any more money on this. So I'm going to get that replaced. Cat it out first. I'm going to find what spindle I'm going to use. Okay, I have a better idea. So I was saying that I was going to mount a V-roller onto the seam and replace that with the aluminum extrusion. I'm not going to do that. I'm just going to replace it with the aluminum extrusion. Keep the MGN printhead. And I'll probably modify the printhead a bit. But I'll keep it on the Core XY architecture and the MGN9 architecture. If I really wanted to, I could upgrade this to an MGN12. I think I have the parts for it. I have an MGN rail on the ender over there. And I could probably find a block somewhere. But yeah, so the main hard part right now is choosing a spindle and how I'm going to do the Z-axis. There is an option that I'm looking into where I just do not do the Z-axis, but I don't know how I would mill stuff with that. So, yeah. I just spent the past 30 minutes staring at this thing and thinking. Okay, so each time I was talking about keeping the Vzbot gantry, I forgot one thing, and that was that we actually need a Z-axis mounted on the gantry. So I have two options right now. I can either go back to a laser cutter, which would be easy. I already have the CAD for it. I just need to cut these extrusions, and then we have a laser cutter. But then, what good is a laser cutter if it can't cut anything I want to cut? So I have some inspiration from this. This is just looks like a CNC built from 2020 extrusions. But I think the way to go on these machines might still be either fixed gantry or, as I said before, where the gantry moves. Again, I don't really like these types of fixed gantry mills, because your build plate has to essentially go double. No, it doesn't. Does it? So you start at that. No, yeah, no, it does, it does. Your machine has to be at least twice the size of your build plates, which is just, it's just stupid. So I'm thinking about a gantry design again, and this is gonna be okay. So we have these motors mounted to plates which I could design, something like that. That we put these two MGN 12 rails on the side here. And then this motor obviously controls that, and then we have the same motor on this side doing the same thing. And then we have a gantry design where we have, I think I'm just gonna go 1 20 extrusion like that. And then we're gonna have, that's gonna be 3D printed. The plates bolting the linear rails to that. And this should be a really easy design because it's just a belt. And then on the x-axis itself, like how the Ender 3 has it, it's probably going to be something similar. I'm not sure how I would route the belts, or where the motor would be. And that's kind of important, so we kind of need to figure out where the motor would be. We could have pass-through holes on the plate where it's mounted. Because I'm just thinking about mounting it with these holes on the side. We could make this shorter and not have be this wide. We could cut it to here, and then we can move this gantry here. And then we could just have the X gantry sticking out of it, so that I can have a motor on the side. That'd also work. And then the X gantry, I'm thinking either I could put the MGN 9/8 rail on there, or I could do a V-roller setup. Both would be pretty simple. I am struggling to decide if... Yeah, both would be simple. Linear rail, if we wanted, we mount it to the top, and then V-rollers, obviously the plate's going to be on the front. Both would be really simple to belt up, because it's just one axis compared to a Core XY setup. I'm going to CAD that out now. That shouldn't be too hard. is that these 4020s have a gap in them, a hole in them that's all the way through. So we could actually use that to route the belts. So that half the belt is inside half the belt is inside the 4020. We have the linear rail for both y-axes. Yeah, y-axes at the side. And then we have a pulley assembly that looks like absolute trash right now, especially this, like, what even is this? But it's okay. This is a proof of concept. And then the linear rail, obviously. And then I'm gonna design like a riser for this so that we can actually mount the X gantry and the X gantry motors. But this looks like it's coming along pretty well. This should work. In worst case, this is just a glorified plotter, which is also nice. The good thing about this design that I really like is that everything's externally mounted for better or for worse. So inside we have more or less the entire build area, or a very small loss of build area, maybe like 2 centimeters off each side, and then we maintain most of the build area. So yeah, I haven't done this side yet, but this is a prototype. I'm gonna print these parts out and see if we can assemble them. And this cat is absolutely obnoxious. What even is this? All right. So we'll get these printed and I'll get back. Okay, so we have it assembled and printed. So this is upside down right now. The motor would be upside down. But we have the belts running across the entire outside, and this is where the rail would be. The belt runs through inside the C channel. Not the C channel, inside the 40 by. Let me zoom in on that. There we go. So there's a bit of a slight tolerance between the edge of the extrusion and the belt, but I think it's going to be okay. And this runs all the way to this part. This is going to be the front, which is just an idler. And then in the middle will be the rail and then mount points for the belt. Right now I just have it zip tied up. So this is pretty good, actually. I thought this tolerance would be a lot worse, but the belt runs pretty smooth through the entirety of the rail. Yeah, so now I'm going to design the X gantry holder for the linear rail MGN12 that's going to slide on this axis. And we should be good. This is a very nice proof of concept. It is now 3:34. So we've spent the past 3 hours designing this thing. This is version 2. So version 2, what's new about this is that we have integrated spacers onto the idlers to make sure there's not as much flop. I also reduced the size of these, but version 3, which is getting printed right now, will reduce that size even smaller. It's just going to be a simple little round piece, and this will make it much more compact than this. In the front, version 2 doesn't differ that much in terms of the motor. I obviously fixed the issue where the hole was too small for the motor, so that's fixed. We have more travel along the tensioning range. But the biggest difference is that I shifted the entire motor 2 millimeters to the left. So we have a lot of clearance between the belts and then the inner extrusion. So as you can see there, yeah, there's a lot of distance now between the belt and the inner extrusion, so it won't be rubbing against it the entire time. So now we get this. The only problem with this revision is that this is too tight for the idlers. I had a tolerance of 1 millimeter in the CAD, but for the version 3 I changed it to 2 millimeters, 1 millimeters on both sides, because this is too tight to get any movement. You can still get movement, but it's just not very smooth. So yeah, so far it looks very promising. I think we can definitely build a light CNC out of this with like a mini spindle. It shouldn't be that hard. This will also give us approximately the same speed as a Core XY.
because it's not that much different. Still two motors driving the gantry. If anything, we get more speed because we have three motors on the gantry instead of two. But no, there's no way we're getting more speed because the Vzbot is way lighter. Never mind. And I can either stop here today, or I can continue CADing the linear rail things. I think I'm gonna wait for version 3 to finish up, and I'm gonna clean this mess up, and then I could get a prototype gantry out. I think the gantry will be the easiest part because this is hard primarily because I need to figure out spacing within the extrusion to route the belts. Because I wanted to do that because it makes it really compact. Look how compact this thing is. It's just that. And that's an entire motion system. So yeah, it's progress. And we eventually do need to cut down the 40/20s. I haven't decided what length I'm going to go to. But I think until we have a full CAD done, this is about as far as I'm going to get. Yeah, so this is looking like we probably need, I want to say, 2 to 3 more days to finish this project, which is a lot. And I haven't even ordered spindles yet or figured out electronics. Electronics, I've been looking into it, and so far everyone's using an Arduino Uno, but I'm pretty sure you can. There's someone who made a Clipper mod for that. But yeah, so no lead screws, fully belt driven. Though I haven't, I shouldn't say that. I might use lead screws for the x-axis. Lead screws plus V-rollers. I don't know how well that will work out because normally V-rollers are used with belts. But, or I could go lead screws plus those LMU 8mm linear rods. I don't really like linear rods. Linear rods assemblies are really bulky, like the one on the Prusas. Because you have to have the entire printhead basically wrapped around those two rod bearings. I think I would prefer just, you know what? We could just strap a 40/20 on there. That one from the end. We could just put that on the x-axis. And have V-rollers going onto it. Or we could have both. We could have V-rollers around the extrusion, and then we can have two linear rods around it. Yeah, we could do that. I think that would make up for our lack in rigidity. I think that's a viable option. We just have, so in the middle would be extrusion, and then on both sides, on top and the bottom, we just mount it like that. And since I'm designing whatever plate this attaches to, I can totally incorporate that. The plate is going to be really simple. It's just, the plate is literally going to be just adapt a single flat plate, adapting the holes on this thing to the belts, which are just a notch. So a notch, the belts run through here, and a notch here, and then wrap around, and we tie that with a zip tie to secure the belts. And then it goes upwards to just support 3 things, the rods and the gantry. If we're doing lead screws, figuring out motion would be really easy because you just also happen to mount a motor on each side of the block. With how many stepper motors I have, I could probably do 2 motors coupled on the x-axis. I don't know how beneficial that would be, but I have a lot of these cheap motors because the X5 SA came with like 4, and I replaced all of them with LDOs. Yeah, no, that's totally feasible. And I have motors from the Ender that are still left over. I could make use of those. Yeah, I'm definitely going to look into V-rollers plus the rods for increased stability. You know what we could do? Most people would just have these in a single line, so that these are all in line with each other. But if you offset them, that gives you more structural rigidity because then you're constraining more degrees of freedom. I think that might be the way, because these are really thin rods, in the world of CNC. I haven't decided on what spindle I'm going to go to. I think I'm just going to go buy the cheapest one on Amazon, which is like $30. Yeah, this is looking very viable. I really like the way this turned out. I can't wait for the version 3 to be printed with the more compact idler mounts. I think this could be great, because this is what drives the entire ender system. The main thing I'm worried about is weight. Are these belts and motors going to be able to accelerate that gigantic load of if you put this on there? I might need to buy more steppers. I might need to look into NEMA 23 like 50mm steppers. These are not the ones I'm going to be running, by the way. These are just the Tronxy ones. I might run this on the x-axis or the z-axis. But for the z-axis, I'm actually looking into putting one of those pancake stepper motors on there, like the ones from the Orbiter, or there's another NEMA 17 stepper that I could put on there, because those are way lighter than this. Yeah, we actually have one here. So we could put that stepper on there, because all the stepper does really is just move a 500-ish gram object, maybe 700 grams, up and down. And not like constantly, but just like it's a one time per like 5 minutes based on my feed rate. That's what I'm thinking for the z-axis. For the x and y, I'm going to be using the Elgios Speedies, because those are going to carry most of the weight down these two gantries. X gantry will, if it's a lead screw, it won't have barely any weight on it, because the router head is going to be way lighter compared to the entire gantry. Oh, I might not need V-rollers. I could totally, you know what? I could use the carbon fiber again. I could do carbon fiber plus those two linear rods. That would save on weight, and that would, yeah, no, that's a brilliant idea. First ever carbon fiber CNC gantry. It's gonna snap in 2 days, but I really like that idea. I might go with that. This means I can return both the Amazon packages, the standoffs for the printhead, the N5 screws probably too, because I found a bunch of M5 screws on the ender as well, and this pile. So I'm gonna return both of those, and those together were like $20. So that puts us at $180 for the milling machine, the $40 protective face shield, and then the $30 aluminum cutting disc. So yeah, that puts us at $180 in total for tools. Okay, so today we're going to be de-anodizing these black anodized aluminum plates. We're going to do this with some sodium hydroxide solution. So here we have sodium hydroxide, otherwise known as lye, used in making soaps. Sodium hydroxide is corrosive, obviously, that's why we're using it to anodize. So we need a plastic container. This is made of polypropylene, but high density PE would also work as well. Just be careful to avoid glass, because sodium hydroxide can etch glass. Though if it's just for a while, it would probably be safe, because it only etches it at like a few microns per minute. But still, it will react with the silica in glass. So always use a plastic container. So yeah, we're gonna make around, I want to say a 0.5 or 0.2 molar solution of sodium hydroxide. But I'm gonna go ahead and clean this container first. It's very dirty. just gonna drop a piece in. You should see some bubbling happening very soon. Okay, so this is version 3 that I have printed. The main difference between this one is that we have the really compact idler system that moves really smoothly as well. I fixed all the tolerance issues in these two spacers. So this is good. I really like this design. And then we have a nicely spaced belt path down the middle of the extrusion with great clearance on both sides, and it's perfectly centered in the middle. And then on this side, for the version 3 motor mounts, this added brace here really helps with the torsion of this entire motor mount. And don't forget, we still have the bottom supports for down here that I don't have printed because I don't have an X extrusion yet. But I am extremely confident in this motor mount. And I think for the final revision, I'm going to make all these mounts. Right now, this is at 5 millimeters thickness. I'm probably going to make it 8 or 9 millimeters thickness. And that will be more than rigid enough. Actually, this is already rigid enough, just with the added brace compared to it without the brace. But, thicker will make it structurally more rigid. I really like this belt path. This is extremely clean because it goes all the way through the extrusion, and only one side is exposed. So it's a really compact motion system, which is always good. This gives us more space internally for milling. So yeah, this is the current state of things. I am still really impressed by this mount, this idler mount. It's gorgeous.